Hey everyone, welcome to this Data webinar. My name is Cedar Shen. I am a product marketing manager here at Data, and I'm also a contributor for the StarRocks project. Let's give it a bit for everybody to join. Okay, so today's topic is why Apache Druid cannot handle modern real-time analytics. So Apache Druid is a very popular OLAP database, a real-time OLAP database that was started in 2011, open sourced in 2012, and Apache licensed in 2015, right? It has been known for its incredible real-time ingestion capabilities and query performance, especially for aggregated queries at the time. Right? In my opinion, Apache Druid is really the first OLAP database that can handle on-the-fly aggregations comfortably, right? So you don't have to build a pre-computation pipeline for your aggregated queries and do like self-service, multi-dimensional analytics, right? And but many years has passed since the system was designed and the core is implemented. And for modern real-time analytics workload, people are asking for more. So better performance, better ease of use, and they want more of their scenarios to be real-time. And here is where Apache Druid is kind of falling behind a little bit. So, so in today's webinar, we're gonna mainly talk about that, right? So let's go over the agenda for today. So first, we're gonna talk about real-time analytics and its use cases, right? So success stories from industry leaders like Airbnb. So all of this case studies are from the StarRocks community. And we're going to talk about the requirements of modern real-time analytics. So what are the users looking for now in 2023, right? And also what Apache Druid is lacking. We're going to do a short technical deep dive into the system, right? And also we're going to explore some other alternative solutions, open source alternative solutions. And how are the challenges that Apache Druid cannot solve yet are being solved by other innovative solutions, right? And then we're gonna go into a success story of Airbnb. Okay, let's get started. So real-time analytics. So what is real-time analytics? I'm sure everybody already know if you sign up for this webinar, right? So it's basically you have your data and so shorten the time from the production of the data to the insight, right? So keep your data fresh and keep the query fast, right? So the first case I want to talk about is Airbnb. So Airbnb is a household name, right? They're a hospitality platform, and they have users and listings from around the globe, right? And it's very important because they're big, they operate internationally. It's really important for them to detect fraud and do it fast, right? And they really want up to the second insight to flag questionable bookings and spots suspicious patterns and detect fake reviews, right? Many other things. So by doing that, by preventing all of the fraudulent activities, they can they can prevent a lot of losses if they can do it fast enough. And also this is the way for them to maintain the user's trust, right? And the second case is Red, and this is a kind of like an international social media platform. They have around 200 million monthly active users, right? And this is more like a user-facing, real-time user-facing analytics scenario. So it's a social media platform, and the way they make money is they sell ads, right? So advertising. And what they have is that they have a kind of like a platform for all of their advertisers. So the advertisers can go to the platform and customize the dashboards, right? And see exactly how well their ads are doing. So they can adjust their strategy based on that, right? It has to be real time, because the faster you can detect that your advertising strategy is kind of off, right? You can prevent more losses, thus, making more revenue. You're on the platform. So if the advertisers are successful, so they're gonna stick more with the platform. So red is gonna generate more revenue from that, right? So it's really help the advertiser optimize their ad strategy, so to enhance their return of investment on the platform. Right, so win-win situation for both. And then it's a logistic company, right? The JD Logistics, and this is one of the biggest logistic platforms in the world, right? In terms of a number of shipments per day, right? And they have it's a really big logistic corporation. They have hundreds of thousands of delivery drivers on the road every day, right? And they have this internal real-time analytics platform, right? They have internal dashboards and reports, and they use it for tracking the shipments and monitoring the deliveries, monitoring the vehicles that's on the road, right? And by doing everything in real time, so they can streamline their shipments, and they can have more accurate delivery estimates, and that's not only good for the customer, and that's good for the delivery drivers too, and that's good for scheduling, right? Route planning and many things, right? So that not only increases customer satisfaction, it also makes their operation so much more efficient, right? And this is a huge part of their business. And now we have looked at some use cases, and now we can discuss what people are asking, right? What people are looking for their real-time analytics workload in the year this year 2023, right? And the first one is performant query, not only a single table, but for multi tables as well, right? And here I'm gonna explain why. So first, we want to take a step back and take a look at different table schema designs, right? And you have Snowflake and Star schema, and those are really multi-table schema, so they're relational, right? And you have another kind of schema as kind of by itself. It's the flat table schema, right? So it's a single table schema. So all of your data, all of your metric are in a big flat white table, right? And that's a flat table schema. So normalization, denormalization. So normalization is basically you turn your flat table schema into your Snowflake or Star schema, into your multi-table schema, right? So it does a lot of good things. So first, eliminates redundant data, and then it actually simplifies the query process. So every time you query, you don't have to look at a table that has like 500 columns, right? And ultimately, it improves workflow, right? And another way around is denormalization, and this is what I've seen a lot in the industry now, because a lot of the OLAP, especially real-time OLAP database, they cannot really handle multi-table joins well. So the database vendors just choose not to optimize it, and they depend on the users to perform a workaround, denormalization, right? So going from a multi-table schema, like a Star or Snowflake schema, back to a flat table schema, right? So they can bypass the join operation in SQL, right? And this can be troublesome. This can be problematic, right? And this really makes a expensive kind of data pipeline, right? So let's see here, right? So you have a table, two tables here, a customer table and an order table, right? And you denormalize this on some sort of key, right? And okay, so one day, the customer name column, your legal team comes over and say, okay, this customer name, we have to somehow mask it, right? It cannot be the actual name of the person of the customer here. So it has to be some kind of hashed value, right? For privacy reasons. So not only you have to change this original table, right? And this is, the customer table is probably small. It's probably only like, 10,000 rows, but you have to backfill all of the data in your denormalized flat table as well, right? And this can be a much, much larger table because it has all of the records in the order table as well. The order table, the fact table can be, millions or hundreds of million rows even, right? And the data backfilling. So you want to change a column, it requires a lot more work if you are performing denormalization in your data pipeline, right? So denormalization actually locks the data into a single view format, so it has like little flexibility to adapt to any business change, right? And not only is it rigid, it also makes a very complex, expensive data pipeline, a real-time data pipeline, right? And for real-time analytics, time constraint is there, so you cannot really use like a traditional batch analytics tool like Spark to perform this denormalization, right? So you have to turn to a stream processing tool and configure stateful streaming processing jobs. And streaming processing tool is known to be difficult to kind of maintain. It's an infrastructure level software, right? And it's pretty difficult to use, right? So if you want to build denormalization pipeline under real time constraint, right? You have to suffer through this, right? And then the next requirement for real-time analytics, I think, is real-time data updates, right? Mutable data is basically everywhere, right? In the beginning of real-time analytics, people are majoritarily doing things like monitoring, log analysis, right? And those are kind of naturally append only data, right? But as people kind of explore more opportunities or more scenarios and move them into real time, and they see mutable data is as a kind of like one of the biggest bottleneck, because a lot of the real-time OLAP database that just doesn't support like real-time data updates. That's for a lot of reasons, but it's mainly, the OLAP databases are built for query and uses columnar storage, and that's really not update friendly, right? So without the ability to perform data update or support real-time mutable data on a database level, so you have to basically kind of work around it, right? If you still want to bring your scenario into real time, so you have kind of a few options, right? You can resolve it at query execution, which means that you append basically every change of the record, and you merge the record at query time, right? And this is one way. Or you can use a external stream processing tool, like you can use Kafka, and two Kafka topics, and you merge the updates before you do the ingestion, right? But whatever workaround out there it is, it's pretty troublesome. It's none of them are actually easy to use, right? So users are saying, now I want my database to natively support data upserts. And the next requirement there is taking full advantage of the cloud, right? Public clouds has gained a lot of popularity in the past 5 to 10 years, right? It really help us reduce labor, right? It's to get started. It's basically free, so there is no like fixed cost, but it can be expensive, right? It's the like for AWS, for instance, EC2. If you just turn on EC2 and run that for a full year, it's very expensive. But the cloud is actually affordable if we're using it correctly, right? So if we're taking full advantage of cloud's elasticity, the nature of cloud elasticity, right? So for any kind of workload in OLAP, there's no workload that's always 100%, right? There's always some fluctuation to the amount of job there is, right? So it's really essential for the database to be able to dynamically scale up and down based on the demand of the workload, right? So this way we can take full advantage of the elasticity of the cloud and actually get better cost efficiency on the cloud than on-prem, right? So so there's that, the requirements, and here we're gonna talk about why Apache Druid is kind of falling behind in the modern real-time analytics scene, right? So first is performance, right? Especially multi-table performance. So let's just look at some benchmark results. So here are three kind of popular real-time OLAP databases. It's a query performance test on the SSB dataset. So this is actually the SSB flat variant. So the original SSB benchmark test is multi-table, but this is made by the folks at ClickHouse. So they basically did a denormalization on all of the tables into a big flat table. So the benchmark test is actually only on that one table. So it's a single table test, right? You can see that Apache Druid is falling behind a lot, and StarRocks is actually 8.9 times faster than a Druid on the SSB benchmark test open box, right? There's no configuration, right? And the reason for Apache Druid's unsatisfactory performance when compared to like more modern OLAP database is because it's written in Java, right? And in Java, it's really difficult to, I'm not saying it's impossible, but it's very difficult to utilize modern SIMD instruction sets, which can be really beneficial for OLAP database, when paired with columnar storage and vectorized execution engine, right? SIMD optimization is an important piece in the performance puzzle, right? But sadly, Apache Druid just cannot take full advantage of that because it's Java based, right? And then this is the bigger issue. Single table Apache Druid just a little slow, but for multi-table, Apache Druid has very little support for multi-table queries, right? It used to not support join at all, but they recently started the effort of adding join support into the database. But I think the essential thing for join is the ability to perform data shuffling, right? Like all of the OLAP database we talk about here are distributed OLAP database, right? Which means that you can scale the amount of data you process and scale your performance by adding more nodes, right? And running join operation under a distributed environment, the most important thing is basically to distribute, is how you distribute all of the data all of your data from the, let's say, the two tables you're trying to join together, how to distribute the data to the appropriate work nodes, right? And one thing that a lot of the batch tools like Spark or even the older MapReduce, what they do is shuffling, right? Data shuffling is data shuffle between on the join key, right? So they can redistribute the data at query runtime, right? But Apache Druid's compute architecture doesn't really support this data shuffling operation, which means that there's only like kind of like two bigger options for Apache Druid, right? To perform distributed join. So first is a co-located join, right? So basically, you distribute your data. So your data distribution needs to be pre-configured according to the query you're gonna run in the future, right? So it's gonna be pre-shuffled, right? Or else can do a broadcast join, right? So broadcast join can only work for joins that has a very small left table, because the left table has to fit in the memory of each one of your worker node, right? So the whole total like memory consumption doesn't really, not only depends on the data side, not only scale with the data size, it only scales with the number of nodes you have, which is kind of dumb, right? And it's not very scalable, and one node can easily be a bottleneck of your whole system, right? Just without this, Apache Druid is never going to support joins at scale, right? So the third is the architecture of Apache Druid. So Apache Druid really has a complex architecture. It has 6 services and 3 external dependencies. Think 3 are external storage and a metadata layer, right? And things. And it's the more component you have and the more dependencies you have, the easier that something can go wrong, right? And this makes Apache Druid kind of really difficult to operate and to maintain, right? And Apache Druid doesn't really scale as well on demand. So it has a deep storage, which acts like, which is used for data persistence. It can be an external like object storage or external like HDFS storage, right? It solves the storage cost problem. So it utilizes the cost efficiency of those distributed storage, but it doesn't really, it's not really a storage and compute separated design, because Apache Druid doesn't really have the ability to query its deep storage directly, right? It needs to do a preload before the query, right? So you cannot really scale based on the workload like dynamically, right? So then let's talk about some open source alternative. So StarRocks. So let's first take a look at the StarRocks performance numbers. So if there's one thing that I can trust StarRocks to do well, it's incredible join performance, right? So here is the same benchmark test we looked at earlier. So the SSB benchmark test. So we looked at the first 3, right? StarRocks, ClickHouse, and Apache Druid flat, and this is on the flat table schema that ClickHouse developed. And here in this, I added another one called StarRocks multi-table, right? And this is actually StarRocks running on the original SSB benchmark test. So we can see that here, StarRocks multi-table performance is actually faster, more than twice as fast as Apache Druid's single table performance, right? So by switching from Apache Druid to StarRocks, what you gain is that you don't have to do any optimization anymore, right? So no more denormalization, no more complex data pipeline, real-time data pipeline. And also you still get the performance boost, right? And this is something that's incredible, right? And also StarRocks features a simple storage and compute separated design. So a true shared data architecture, right? So it only has two kind of processes. So front end and the compute node, right? And data is persisted in external storage, like external distributed storage. And compute nodes can actually directly query the external storage directly. And the local disk of the compute nodes are only used as a cache, right? And this cache ensures that despite we're querying directly from the distributed storage, we still get the same amazing performance as we're persisting the data in our local storage, right? So this architecture allows StarRocks to dynamically scale. So during a query, like in your production workload, right? If the demand drops, StarRocks can respond to that change of traffic in seconds, right? Because you can drop a node and still have access to all of the data in the distributed storage where the data is persistent, right? And also StarRocks has native real-time update support or real-time upsert support, right? And that's with the primary key index, right? So in StarRocks, you have the option to build a primary key index. So the index basically stores the hash value of the primary key and where exactly that row of data is stored in the storage, right? So during query execution, StarRocks can transform all of the data updates, data upserts into a delete and insert kind of operation, right? And during query ingestion, handle all of the data upserts in place. And this is accelerated by the primary key index, right? And so this way we can support real-time mutable data, right? And because all of the upserts are taken care of in during query ingestion, so this has absolutely no negative effect on the query performance. So here, let's do some recap, right? StarRocks versus Druid. So StarRocks supports native multi-table query at scale, where Apache Druid lacks on join, has very little support on join, and without data shuffling, it cannot really perform join at scale, right? Big table, join, big table, no. And StarRocks has a simple architecture with no external dependencies. And Apache Druid has a kind of complex architecture with many dependencies, right? And StarRocks features a true shared data architecture, and that's built for the elasticity for the cloud, right? You can dynamically scale with StarRocks architecture. But with Apache Druid, the deep storage doesn't exist in the query path, so you cannot really dynamically scale your nodes based on the traffic, based on your workload, right? And StarRocks has a native real-time data update support, where Apache Druid doesn't have that. So you have to work around the real-time data update by either the ways we talked about before, right? And here, let's take a look at a success story from Airbnb. So this is Airbnb's Minerva platform, and it holds, I think, 6 petabytes of data, right? So it's the internal metric platform that everybody uses, right? So before they were using Apache Druid as the query layer, Apache Druid and Presto as the query layer, right? And because Apache Druid cannot really handle join at all, so they had to denormalize everything, right? So denormalization is a kind of like a default when they were using Apache Druid, and that created a lot of problems, right? And firstly, the denormalization pipeline is difficult to manage, and it uses a lot of compute resource, and it wastes a lot of storage space. And they were denormalizing the data they were never gonna use, right? And second, it makes the data pipeline rigid. So every time they want to add a new metric, they want to change a metric, it often takes up to, from hours up to days to do that. But for a business like Airbnb, it's just not acceptable, right? And then they went to StarRocks. They changed to StarRocks because StarRocks can handle joins very well, even on petabyte scale, with the 6 petabytes of data they have. So the biggest change for them was denormalization wasn't default option anymore. So after they switched to StarRocks, denormalization is reserved for only selected scenarios where where the query is very complex or the concurrency requirement is very high, right? And this really saved them a lot of labor, like building the denormalization pipeline, and makes everything streamlined, and metric change it's just not a problem anymore, right, with StarRocks. Okay, so here is everything I have. You can visit the Cellular Data blog here, sign up for Cellular Data Cloud for a credit card free 30-day free trial, and also join the Slack channel. And here is a GitHub repository. Give us a start there. Thank you. And you can connect with me, c-n.com. This is gonna take you to my LinkedIn page. So thank you for watching.